So geometry, 1.6, describing pairs of angles. So how can you describe angle-pair relationships and use the descriptions to find angle measures? So we're going to have some keywords here. We're just going to jump straight in past the exploration. Didn't really like it as much today. And what we're going to look at is we have these 5 different names, and we got to know these names. Okay, these are going to show up a lot. They're going to keep coming up, and we have to know what they mean when we see that word. Okay, so complementary angles, supplementary angles, adjacent angles, linear pair of angles. We can add that to that, a linear pair of angles, since they all have angles in them, and vertical angles. Okay, some of these may look familiar, some of them could be a little new. Okay, complementary angles, down here. 2 positive angles whose measures have a sum of 90. Okay, so they have to add to 90 degrees. Each angle is the complement of the other. So the complement to angle 1 would be angle 2. The complement to angle 2 would be angle 1. The complement to a 20-degree angle is a 70-degree angle. The complement to a 70-degree angle is a 20-degree angle. Okay. This diagram here, we're going to see this in a little bit, but this diagram is an example of adjacent complement angles. And adjacent means they're going to share a side. Adjacent means they're going to share a side. So angle 1 and angle 2, this is our shared, what we call a shared side. Okay, so I'm going to hop that in there as well. These are adjacent. These would be the non-adjacent. These are just random ones. Okay. Things to add: if an angle measures x degrees, so if you don't know this specific, but you know it measures x degrees, its complement is written as 90 minus x degrees. Okay? So if a measure is x degrees, its complement is written as 90 minus x. Okay? So if this is x here, if this is x degrees here, this angle would be 90, the total minus the other part. We saw that in the last lesson, the total minus the part. So if you have one part and you have a total, you take the total minus the other part to get the other angle. So x and 90 minus x. Okay, supplementary angles, 2 positive, they have to be positive again. Negative angles may be new, but when you get to advanced math, you're going to be dealing with negative angles. And it deals not so much with a physical object of an angle, but it deals with an amount of rotation. An angle is how much you're rotating. If you rotate 90 degrees or you rotate negative 90 degrees, it deals in the direction you go. So 2 positive angles whose measures have a sum of 180. So they have to add to 180 degrees. Each angle is the supplement of the other. So the supplement to angle 3 is angle 4. Supplement to angle 4 is angle 3. Supplement to 115 is 65. To 65 is 115. So they are supplementary angles. Now again, we have a unique one here. These are adjacent. These are adjacent. This is a shared side. And this one actually has a special name. These are called linear pairs. 3 and 4 would be a linear pair. Now remember, linear makes a line. So linear pair is when you have a line and one ray coming off of it. Okay, that makes a linear pair. A line with a ray coming off of it. So a linear pair is a line with a ray connected at its endpoint. Not sure why they call it an endpoint for a ray. It seems like that's where it starts. These are supplementary angles as well. So they add to 180 degrees. That's a plus sign. Add to 180 degrees. Okay. Adjacent angles. Adjacent angles are 2 angles that share a side. Remember, the sides are the rays. So we can say they have a common ray. The sides are the rays. They have a common ray. So back to the supplementary angles. if an angle, so if an angle measures x degrees, how would you write its supplement? It should be written, not written. Its supplement is written as 180 minus x degrees. 180, the total minus the part. Okay? So if they would have the example, an angle is 4 times its supplement. Find the measures. An angle is 4 times its supplement. So an angle, that's x degrees, is 4 times its supplement. That's 4 times 180 minus x. Okay, so x degrees is 480 times its supplement, 180 minus x. So x equals 4 times 180 would be 400. 4 times 100 is 400. 4 times 80 would be 320. So 400 plus 320 would be 720 minus 4x. Add the 4x over. We get 5x equals 720. 720 divided by 5, we get 144. So you get x equal to 144 degrees in that case. Its supplement would be 36 degrees, which is 4 times 144 is 4 times 36. So that's how you can use these terminologies to set up some equations like that. Okay, so we already talked about here adjacent angles. So adjacent angles are two angles with a common vertex and side. I guess we can add vertex to that as well. Not just a common side, but a common vertex. Side and vertex. Well, how can you draw two angles that share a side but not a vertex? It might be something like this. Angles 9 and 10. Okay, they kind of share a side there, but they don't share a common vertex. So those would be non-adjacent angles. Okay, so here are adjacent angles. It can be angle bisectors that we saw in the last lesson. Those can be angle 5 and angle 6. They're adjacent angles. Okay, it just has to have a common side and common vertex. Now, when you get two adjacent angles that are a linear pair, when they're non-common sides, they're opposite rays. So these right here, these are called opposite rays. Opposite rays. So they will have the same endpoint. Point in 180 degrees from each other. So they'll point in a straight line. So they would form a line. This right here, this is an opposite ray. So that one and that one, that's what they refer to as opposite rays. I like to just think of it as it's a line with a ray coming off of it. Okay? You get linear pairs and they're vertical angles, and these are also supplementary angles. Okay, last one are called vertical angles. I sometimes call them opposite angles. Okay, vertical angles are opposite angles. So what you do to make these, you're going to intersect two lines. I'm just going to draw two lines. I'm going to intersect them like that. Now, angles opposite each other, those are what they call the vertical angles. And we'll have the same degree measurement. Okay? So they have 4, 3, 5, and 6. 3, 4, 5, and 6. So what we say here is 3 and 6 are vertical angles. We could say the measure of angle 3 equals the measure of angle 6. So 3 and 6, those two right there would be vertical angles. And then these two right here would be vertical angles, 4 and 5. And they're congruent, they're equal. I could say the measure of angle 4 equals the measure of angle 5, or I could say angle 4 is congruent to angle 5. Remember, the shapes are congruent, the measures are equal. So, your practice, page 31. One page of it, all right. Name the pair or pairs of adjacent complementary angles. So adjacent, they have to share the same side and vertex, and complementary, they have to add up to 90 degrees. So here, 15 and 105, they don't add up. There'd be adjacent angles, KJL and LJM, but they don't add up to 90. I see a 90-degree angle here. I see a 75 and 15. Those add up to 90. So TOS, so angle TOS, and TOP, top. So those would be adjacent. They share side OT, and they add up to 90 degrees. And I think that's it. Now, this 15 and 75 would add up to 90, but they're not adjacent. Name the pairs of non-adjacent supplementary angles. So we have 105, 15, we got 75. Non-adjacent, we could go, here's a 90, here's a 15. You see this 15 here? Let's go angle KJL. There's 15, and we're going to replace this one so it's non-adjacent. SOQ, angle SOQ. Those would be supplementary angles, but non-adjacent. Okay, anything else? 75. We could do... Okay, 105 and 75, those are adjacent. They are supplementary, but they are adjacent already. So another 75, those would be adjacent and supplementary. 90, how about the 105 here? This 105 could go with either of these 75s. So we could say, okay, measure of LJM, angle LJM, that is supplementary to TOP, angle TOP. You say angle LJM is supplementary to QOR. Okay, let's move on. That's what you're doing with those. You're trying to look at, well, what angles can you find? So it may just take some time to think, time to process that. Find the measure of the angle. Angle A is a complement of angle B, so 90 degrees. And measure of angle A is 936, so if that's x, angle of B needs to be 90 minus x, so that's 90 minus 36, which would be 54 degrees. C is a supplement. Supplement, you got to be thinking 180 right away. Of angle D, D is 117, that's going to be our x value. C is going to be 180 minus x, so that's 180 minus 117, that'd be 63 degrees. Find the measure of each angle. Okay, we have a 90-degree angle. We have 10x plus 22 and 7x plus 34. We do not know if that's a bisector, so we do not set them equal to each other, but we have two parts, and we have a total. When you have a total, it means you have to add stuff usually that will equal that total. So I'm going to say 10x plus 22 plus 7x plus 34 equals 90 degrees. Equals 90 degrees. Okay? So I'm going to take these two individual parts. I'm going to say the measure of angle BAC plus the measure of angle CAD equals the measure of angle BAD. So the two smaller ones add to the total. So add them together, 17x plus 56 equals 90, minus the 56, so 17x equals 34, so x equals 2. Find the measure of the angle, so I'm going to go back and plug it in here. 10 times 2 is 20, 20 plus 22 is 42 degrees. The other one should be 48 if they're adding to 90. 7 plus 2 is 14. 14 plus 34 is 48 degrees. So there's your two angles. Make sure you put them in the right spots. Okay, this one they give you a linear pair. Linear pair, so that means they add to 180. So 6x minus 5 plus 12x plus 5 have to equal 180. That's going to be a big part when we get to some of the tests and quizzes and review, is when will we set angles equal to each other, such as when we have bisectors, and when do we set them, add them, and set them equal to 90 or 180 or another number. So 18x, 5's cancel off, equals 180, so x equals 10. So this would be 55 degrees once you plug the 10 in, and this would be 125 degrees. Check. 55 plus 125 is 180. Angle 7, identify the linear pairs that include angle 1. Linear pairs. So here's angle 1. Linear pairs have a line. So angle 1 is formed by this line going up and down. Get a different color. So that would be angle 4 would be a linear pair. And then also this line going left and right, so that would be angle 2. Those are the angles that form a linear pair with angle 1. Identify the vertical angles. Well, vertical to angle 1 would be angle 3. Okay, if we're referencing angle 1, that would be angle 3 would be a vertical angle. 2 and 4 are vertical angles. That would be another pair, 2 and 4. You could go here, 5 and 8 are vertical angles. 10 and 7, 6 and 9. Okay? So if we're going to list all of these, we could say angle 1 and angle 3, angle 2 and angle 4, angle 5 and angle 8. Okay, I want you to see that. The two lines that form 5, if I cross that all the way through, I'm going to see the angle that's opposite it. Angle 10 and angle 7, and then angle 9 and angle 6. Are 6 and 7 a linear pair? No. They're non-adjacent sides. They do have an adjacent side. They are adjacent. Angle 6 and 7 are not opposite rays. Okay? So when they're asking for something that's a definition. We talked about linear pair and what that definition is. You can always go back to that definition. It says a line with a ray connected to its endpoint. Okay? Their linear pair said two adjacent sides when their non-common sides are opposite rays. The angles in the linear pair are supplementary angles. So it's like, oh, it violates that. That's why they are not opposite or a linear pair. So this wraps up the notes for Chapter 1. We're going to be reviewing and taking a test here soon. Let me know what questions you have, and we'll see you in our next class. Go Bluebirds!